Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 2.4, Problem 9. This is Section 2.4, Problem 9. It says multiply the matrices. And we have 2, -2 as the top row, 1, -1 as the bottom row, times the matrix 4, 3 as the top row, 1, 2 as the bottom row, and then plus 2 more matrices multiplied, 2, -2 as the top row, 1, -1 as the bottom row, times 7, 0 as the top row, -1, 5 as the bottom row. So there's a lot to do in this problem. You need to do the multiplications first and then add the 2 matrices that you have after you do the multiplications. So and that's just like regular numbers. You have to work in parentheses first, then you have to deal with any multiplications or divisions, then you have to do any additions or subtractions last. So now, let me concentrate on just multiplying the first 2 matrices first, and I'll ignore the rest of the problem for now. So I'm going to multiply 2, -2 on the top row, 1, -1 on the bottom row, times 4, 3 on the top row, 1, 2 on the bottom row. So first, as usual, you want to verify that there is a solution to that. So to do that, you want to see if the number of columns in the first matrix is equal to the number of rows in the second matrix. And the way we usually do that is we write the dimensions under each matrix and see if the inner numbers match. So when we write the dimensions under the first matrix, the dimensions are 2 by 2. The first matrix has 2 rows and 2 columns. Therefore 2 by 2. And the second matrix also has 2 rows and 2 columns. So that when you write the dimensions underneath, the inner numbers do match. They're both 2. So this does have a solution. And the solution will be 2 by 2. And I get that because that's what the outer numbers of the dimensions are. So the answer I'm going to get will have 2 rows and 2 columns. So as usual, I'll set up the boxes that I'll do the work in, and then I'll just write the answers after. So the answer will have this format: 2 rows and 2 columns. As I set up my boxes like that, I'll write the work in there. So to start this off, I'm going to multiply the top row of the first matrix, 2, -2, times the first column of the second matrix, 4, 1. So when I multiply that, I will multiply first times first, which is 2 times 4, plus second times second, which is -2 times 1. So first times first, 2 times 4 gives me a result of 8, plus second times second, -2 times 1 is -2. So 8 plus the -2 is really 8 minus 2. Gives me an answer of 6. And now, where did the 6 go? It went in the top row and first column of the solution because I multiplied the top row of the first matrix times the first column of the second matrix. So next, I'll multiply the top row of the first matrix, 2, -2, times the second column of the second matrix, which is 3, 2. So first times first is 2 times 3. Plus second times second is -2 times +2. And first times first, 2 times 3 is 6. And then second times second, -2 times +2 is -4. So 6 plus a -4 is really 6 minus 4, which is 2. And I got that answer by multiplying the top row of the first matrix times the second column of the second matrix. So my answer went in the top row and second column of my solution. Now, next I'm going to do the bottom left box of my solution. So I'm going to multiply the bottom row of the first matrix, 1, -1, times the first column of the second matrix. So I'll multiply first times first, which is 1 times 4. Plus second times second, -1 times +1. And when I multiply first times first, 1 times 4 is 4. Second times second, -1 times +1 is -1. So I have 4 plus a negative 1, it's really 4 minus 1, which is 3. And again, I multiply the bottom row of the first matrix times the first column of the second matrix, so I put my answer in the bottom row and first column of my solution. And finally, one last box to fill in for this matrix. I'm going to do the bottom row of the first matrix, which is 1, negative 1, times the second row of the second matrix, which is 3, 2. So first times first is 1 times 3, plus second times second is negative 1 times 2. And now when I multiply first times first, 1 times 3 is 3. And plus second times second, negative 1 times 2 is minus 2. So 3 plus a negative 2, or just 3 minus 2, is positive 1. And again, I multiply the bottom row of the first matrix times the second column of the second matrix. So my answer will in the bottom row and second column of the solution. And I can write that answer without all that work showing. I just write a matrix with a top row of 6, 2, and a bottom row of 3, 1. I'll write it right underneath my work, right here. And I'm going to come back to that answer in a minute when I add it to the result of multiplying the other two matrices in this problem. So I multiplied the first two matrices in the problem and got it down to the answer of 6, 2 in the top row, 3, 1 in the second row. Now I'm going to just let that sit to one side for a minute, and I'm going to multiply the other two matrices in this problem. So the other two matrices being 2, negative 2 in the top row, 1, negative 1 in the bottom row, times 7, 0 in the top row, negative 1, 5 in the bottom row. So you have to verify that there is a solution. And the same reasoning, there is going to be a solution. It's the same dimensions as the first two. So the first matrix has 2 rows and 2 columns, so its dimensions are 2 by 2. And the second matrix also has 2 rows and 2 columns, so its dimensions are also 2 by 2. And when you check the inner numbers, they're both 2. They match, so there is a solution. And the outer numbers, 2 and 2, means the solution will have 2 rows and 2 columns. So even between the work, let me even put a plus sign here just to follow through with what the original problem was. It's the first two matrices plus the result of the second two matrices multiplied together. So let me set up my boxes for the work, where the boxes will have the format of having 2 rows and 2 columns, and I'll start filling those in. And I'll start off by multiplying the top row of the first matrix, 2, negative 2, times the first column of the second matrix, 7, negative 1. So I will multiply first times first, which is 2 times 7, plus second times second, negative 2 times negative 1. So the first times first, 2 times 7 is 14, plus second times second, negative 2 times negative 1 is positive 2. Again, pay attention to the signs. So 14 plus 2 gives me a result of 16. And again, I put the 16 in the spot that I did because I multiplied the top row of the first matrix times the first column of the second matrix. So my result went in the top row and first column of my solution. Now, next I'm going to multiply the top row of the first matrix, 2, negative 2, times the second column of the second matrix, which is 0, 5. So when I do first times first, it's going to be 2 times 0, plus second times second, which is negative 2 times 5. So first times first, 2 times 0 is 0, plus second times second, negative 2 times 5 is negative 10. So 0 plus a negative 10 is negative 10. And again, the work I did was multiplying the top row times the second column, so I put my answer in the top row and second column of the solution. So now the next one I fill in, the next box I fill in, will come from multiplying the bottom row of the first matrix, 1, negative 1, times the first column of the second matrix, 7, negative 1. Now I'm going to start by doing first times first, which is 1 times 7. Plus second times second, which is negative 1 times negative 1. And when I do that work, first times first, 1 times 7 is 7. Second times second, negative 1 times negative 1 is positive 1. Again, the negatives cancel. Pay attention to the signs. And then 7 plus 1 is 8. And that 8 winds up in the spot where I put it, I multiplied the bottom row of the first matrix times the first column of the second matrix, giving me a result of 8, and I put that result of 8 in the bottom row and first column of my solution. And finally, one last box left to fill in for this problem. I'm going to do the bottom row of the first matrix, 1, negative 1, times the second column of the second matrix, 0, 5. So now first times first is 1 times 0, plus second times second is negative 1 times 5. So when I do first times first, 1 times 0 is 0. And then second times second, negative 1 times 5 is negative 5. So I have 0 plus a negative 5, which is minus 5. And again, that's the spot it goes in the bottom row and second column of my solution, because I multiplied the bottom row of the first matrix times the second column of the second matrix. And that's the answer, again, shown with all the work. So let me write underneath all my work just the simple matrix with only its answers: 16, negative 10 in the top row, 8, negative 5 in the bottom row. And that's next to the answer that I got from the first two matrices that I multiplied. And now I'm going to add the two results of my multiplications together. So from the first pair of matrices that I multiplied, I had a result of 6, 2 in the top row, 3, 1 in the bottom row. And I'm going to add that plus the result of the second multiplication, 16, negative 10 in the top row, 8, negative 5 in the bottom row. And when you add the matrices together, it's much easier than multiplying. You're just going to combine the numbers in the corresponding positions. So now I'm going to add upper left plus upper left, 6 from the upper left of the first plus 16 from the upper left of the second, giving me 22 in the upper left of my solution. Next, the upper right, 2 from the upper right of the first matrix plus a negative 10 from the upper right of the second matrix gives me a negative 8 in the upper right of my solution. And now on the bottom, I'm going to do 3 from the bottom left of the first matrix plus 8 from the bottom left of the second matrix gives me a result of 11 in the bottom left of my solution. And finally, one more spot, 1 from the bottom right of the first matrix plus a negative 5 from the bottom right of the second matrix gives me a negative 4 in the bottom right of my solution. And that is my final answer now overall. A smaller matrix of 22, negative 8 in the top row, 11, negative 4 in the bottom row.